Hello, everyone. My name is Erica Del Rio, and welcome to my presentation, Applying the TTIPP Model with Padlet. For this project, I designed a fourth grade math lesson aligned with TEKS 4.5D, which focuses on solving problems involving the area and perimeter of rectangles, where dimensions are whole numbers. As a math teacher, I've noticed that while many students can memorize formulas, they often struggle to apply them conceptually or explain what those numbers mean. So, my goal was to move beyond memorization to help students actually see, discuss, and explain their thinking using a collaborative digital tool like Padlet. In this short presentation, I'll walk you through how I use the TTIPP model, the technology integration planning process, to intentionally design this lesson and show how technology can enhance student understanding rather than just replace traditional methods. The TTIPP model, developed by Roblyer and Hughes, is a research based framework that helps teachers plan, implement, and evaluate technology integration in a systematic way. It's divided into three main phases: analysis of learning teaching needs, where we identify problems of practice and available resource; design of the integration framework, where we plan objectives, strategies, and prepare the environment; and three, post instruction analysis and revisions, where we reflect, make improvements, and share results. This process ensures that we're not just adding technology for fun or convenience, but that every digital tool we use directly supports learning goals and student engagement. Phase one begins by analyzing our learning challenges, our problems of practice. In my classroom, the biggest issue was that students could plug numbers into formulas, but they didn't really understand what perimeter or area represented. Many confused them or used the wrong units. To address this, I needed a way for students to see and discuss these concepts. Padlet provided the perfect platform. In my district, every student has access to an iPad, and our Canvas LMS supports embedded external tools. Families often have smartphones at home, and Padlet works across all devices. What I love about Padlet is its flexibility and accessibility. Students can upload pictures of their math models, add text or audio explanations, and even comment on each other's work. Built in accessibility features like translation, captions, and speech to text make it inclusive for English learners and students with disabilities. So at this stage, I knew Padlet wasn't just available, it was the right tool for this purpose. In phase two, the focus shifts to design. Here, I establish my learning objectives. Students will represent and solve problems related to area and perimeter of rectangles. Students will explain their reasoning using numbers, pictures, and words. Assessments are both formative and summative. Students post their solutions on Padlet, comment on peers' work, and reflect on what they learned. I can access their understanding by reviewing their explanations and responses. The relative advantage of Padlet is that it makes learning visible. Instead of isolated notebook work, we get a gallery of student thinking. Students can learn from different approaches, and I can identify misconceptions in real time. Before implementation, I'll prepare the Padlet wall within Canvas, title it Area and Perimeter Explorers, and model what a strong pose looks like. I've also reviewed discussion norms, how to give respectful, math centered feedback using complete sentences and correct vocabulary. Phase three is all about reflection and improvement. I haven't implemented this lesson yet, but if I did, I can imagine what the results might look like. Most students would likely show a stronger grasp of the difference between perimeter and area, especially after seeing multiple examples from peers. The visual nature of the palette would help them connect formulas to meaning. However, not everything would go perfectly. Some students might focus more on decorating their post than explaining their math, and a few might need extra support commenting effectively. In future revisions, I would add feedback sentence stems like I noticed, I wonder if, oh, have you considered to guide peer responses? I've also added a short reflection prompt asking students to describe one thing they learned or one mistake they corrected. Finally, I would share this lesson and the revised version with my grade level PLC so other teachers could adapt it for geometry, measurement, or even science. Padlet stands out because it brings collaboration, creativity, and accessibility together in one platform. It's visual, it's interactive, and it supports multiple forms of expression typing, speaking, or drawing. For English learners, they can use a built in translation or record the responses verbally. For visual learners, they can post images or sketches of rectangles. It meets the principles of universal design for learning UDL by providing multiple means of engagement and representation. By using Padlet, students aren't just learning math. They're learning how to communicate mathematically, give feedback, and reflect on their own understanding. To wrap up, the TTIPP model gave me a structured way to design an intentional, exclusive, and engaging lesson. By walking through each phase, analyzing needs, designing strategies, and reflecting on outcomes, I could see how thoughtful technology integration can truly transfer learning. Padlet helps students make their thinking visible, providing teachers with authentic insight into their understanding. Even though this lesson hasn't been implemented yet, the planning process itself showed me how effective design leads to meaningful engagement. Thank you so much for watching and learning about my TTIPP project using Padlet.